all, welcome to another video of Corpnce. I'm Rono Savio, and in this video we'll be discussing on space complexity. So let's dive in. So now that you're gonna see is nothing but order of log n in space complexity. So example, you can take, let's say in reality you have a dictionary and you're trying to find a particular word, and you literally go through those pages. You don't go through each and every page, right? You go through those pages which has the particular letter for that particular word, the starting letter. Let's say E is the starting letter, and you go for that particular letter in the dictionary too, and you ignore all other letters. Like you don't want A, B, C, D, you'll go directly to E. Same way, even order of log n does space complexity, measures space complexity in such a way. So here we can take an example of binary search, how binary search will break down the steps as it keeps on going. So here I have an example. You can look at my screen. So in my screen, I'm saying I want to find 535. Okay. So in order to find 535, I'll run binary search and I'm gonna pause it. You can see the first thing what it did, it took the two endpoints. Already these values are from 0 to 1000 and I want to find 535. 535 lies at the index position 12. Now it has taken two endpoints at index position 0 and index position 31, and it is taking the midpoint, which is 15. Now the binary search, what it will do, it knows exactly like your dictionary, how you try to find a word. You know, after A, B, C, after C you know it is D, and after D it is E. Exact same way here also, this one took the midpoint and it knows from 629, if you go towards the left side, there you can find 535, because if you go towards the right side, it is incrementing the values. You don't need those. So from 629 to 979, you can cut off those values. So the memory is saved. You can see how it is, breaking down the memory. So now if I play this, or you can say step forward, see that. Look at that, all those values have gone. Now it has taken 604 as the endpoint. Step forward. And yeah, now 7 is the midpoint, and we repeat the steps and it goes towards the right. 8 is the starting point now, and keeps on going, it keeps on breaking down, and then we reach 535 like this. This is how order of log n works. So your memory storage is like reduced as each steps keeps on going, like it is breaking down the steps. So it is like, increasing very slowly, you can say, not proportionally but very slow. So let's understand order of n log n for space complexity with an example of merge sort. So here when you have order of n log n, it is nothing but very similar. Take an example of a library, and in library what you do is, let's say there are a lot of books and you have to store them in section wise. So first what you will do, you split them according to their sections, then you will sort them accordingly. So splitting them according to the sections is what your n log n is, order of log n. But n log n is nothing but sorting them in that particular sequence. So you have that n and log n simultaneously. Take an example of merge sort I told you. So look at my screen. So you'll have a clear understanding of what is happening. So here I have my merge sort. In merge sort what I am doing, what exactly happens in merge sort? Let's say you give some values 26, 34, 54, 23, 12, 10, 11. You have these many values. Then what I'll do, in the first step, your merge sort actually splits those values until you have those sublists as only single values. So see, it splits half, again splits half, again it goes and splits. This is how it works. Now what happens? It sorts them. So 26, 34 is already sorted. It keeps on going. Then 54, 23, it checks, it sorts them. The sorting part, what is happening, the repetition, that is nothing but your n, and the splitting part, what happened, that is nothing but your log n. So that is how order of n log n works together. So here 23, 54. Now same thing goes with this one. You have one single list now. So 26, 34, and yeah, keep going, 54. Yeah. The next one, you do the same thing for this particular broken part, what, like half. You split them until you have single items, then you sort them. So sorting part is nothing but your order of n, and splitting part is nothing but order of log n. breaking down into smaller steps. And you are storing this temporarily until the end. Then once it's sorted, you get it back together all at once. So yeah. Now you have your sorted one. That's how it's working. Also, an important thing, there is two kind of spaces. There is something called as auxiliary space and total space. So when it comes to auxiliary space, imagine it is like a workspace for your algorithm to work on, a temporary space to get the solution, final solution. So imagine you previously saw merge sort, you were creating temporary list of values. So that temporary like storage of those values were nothing but your auxiliary space to get to the final sorted array. But when it comes to total space, you are including that the algorithm includes all the input plus the auxiliary space together. That is nothing but your total space. So in auxiliary space, you won't include the range, like the input n, you won't include that. You will only include the temporary space taken. So that's all for this video, and I hope it gave you a clear understanding of how space complexity works. And if at all it did help you, do subscribe and stay tuned for the next videos. Thank you.